Hello everyone, you are welcome to Mathematics Tour. This is the Cambridge Lower Secondary Checkpoint Mathematics written in October 2024. This is paper 1 and there are 24 questions in this paper. As you already know that a calculator is not allowed in this paper. Let's jump into the first question. Safia has this rule. Start with the number n, so the number will be n, then cube the number, so that will be n to the power of 3, and finally multiply by 7, so that will be 7 multiplied by n to the power of 3. So this will be the algebraic expression for the rule in terms of n. So we have 7n to the power of 3. Question 2, write the correct index in each box. So you have 5 to the power of 1 out of 3. So this is fractional law of indices, and it is equivalent to 5 to the power of -3. Okay, so you just take the 1 out of, okay, to be minus, for instance. Okay, then you have power of -3. Okay, so that is just the simple trick there. So this will be -3. Then the second one, 6 to the power of 5 multiplied by 6 to the power of -3 equals to what? So this is multiplication law of indices. We have two indices, 6 to the power of 5 multiplied by 6 to the power of -3. So they have the same base. So you pick one, then you add the powers. So 5 add -3. So these two signs combine together to become negative. So that will be 5 minus 3. That will be 2. So our final answer is 6 to the power of 2. So you have 2 here. Question number 3. A polygon has 5 sides. The polygon has 4 exterior angles, each measuring 75 degrees. Work out the size of the 5th angle of the polygon. Okay, so if you just have a rough sketch of part of the polygon, so this will be the exterior angle and this will be the interior angle. Okay, so you can just draw down like this. Okay, so what we know is that the sum of the exterior angles is 360 degrees. Okay, so if you have this will be one exterior angle, so this will be another exterior angle. So we have 5 of them, but we are told that the 4 exterior angles, okay, are the same out of these 5 exterior angles. So that means 4 into 75 degrees for the 4 equal exterior angles plus the 5th exterior angle, let that be x. Okay, so the 4 interior angles that are equal, okay, are this, and the 5th exterior angle is x. So everything should add up to 360 degrees as the sum of any exterior polygon, okay, the sum of angles of any exterior polygon is 360 degrees. So this is the fact. Okay, so if you multiply 75 degrees by 4, so that will give you 300 degrees. Add x, okay, then it will be equals to 360 degrees. Then you can solve for x, so subtract 300 degrees from both sides. Okay, so this will cancel out this, so we're left with x equals to 360 degrees minus 300 degrees. That will be 60 degrees. So our final answer here is 60 degrees. So the unit is there. Okay, so let's go to the next question. That will be question 4. The diagram shows a quadrilateral drawn on a coordinate grid, as you can see here. So draw the image of the quadrilateral after an enlargement. Scale factor 3 and center of enlargement is 5, 4. Okay, so this is the center of enlargement. It has been indicated on the grid, and the scale factor is 3. Okay, so the best practice is to label the vertices of this shape. So we can label this A, B, C, and D. Okay, so from the center of enlargement, which is this point, so let's count the steps or step to each of the vertices. So let's start with A. So from the center of enlargement, you go up once, then you come to the left once. Okay, so that is one like this and one like this. So the order is very important. Okay, so that is one here, one here. So the scale factor is 3. So that means we multiply by 3 and we go in the same order. So it will be 3 up and 3 left from the center of enlargement. So from this center of enlargement now, so let's count. Let me remove this. Okay, so from here, let's go up 3 times. 1, 2, 3. Then let's go to the left 3 times. 1, 2, 3. So that means the image of point A will be here. So I can call that A prime. Okay. Then the same thing for point B. From here, 1, 2, 1. So you go like this. Okay. Then you go up. Okay. So 2, 1. So if you multiply by the scale factor by 3, so it becomes 6 and 3. So let's start from the center of enlargement. Let's count 6. 1, 2, 3, 4, 5, 6. So let's count again. 1, 2, 3, 4, 5, 6. So it will be here. Then let's count 3 up. That will be 1, 2, 3. So it will be here. Okay, so I can call this B prime. That is for the image of B. So I can remove this. Then the next one will be point C. So from the center of enlargement, we'll count like this. 1, 2, 1, 2. So you have 2 to the right and 2 downward. So if you multiply by 3, so this becomes 6 and this becomes 6. So from that center of enlargement, let's count 6. 1, 2, 3, 4, 5, 6. Then let's count 6 downward. 1, 2, 3, 4, 5, 6. So the point will be here. So this will be C prime. So you can cross check again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I can remove this again. So the last point will be point D. So from the center of enlargement, let's count. 1, 2, 3, 1. So you count 3 like this, then 1 downward. So if you multiply by the scale factor 3, so 3 times 3, this becomes 9 and this becomes 3. So in this order, okay, that is in this direction. Okay, from the center of enlargement, so let's count 9 to the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 3 downward. 1, 2, 3. So it will be here. That will be D prime. So this will be D prime. Okay, then you can now connect the points together. A prime to B prime. Okay, then B prime to C prime. And okay, you can join D prime to, let's undo that. Okay, so we can join this now, D prime, sorry for that. So we can join D prime to, this is point D prime. So we can join D prime to that point over there, to A prime. And finally, you can join D prime and C prime together. So this is what we have. So this is the enlargement of the object. So it's super easy. So let's go to the next question. That will be question 5. The first term of a sequence is 3. Okay, so you have 3 here. The term to term rule of the sequence is square then subtract 5. So the second term will be, if you square this, okay, square this, then subtract 5. 3 times 3, that is 9. 9 minus 5, that will be 4. Okay, so to get the next one, it will be 4 squared minus 9. Okay, so find the third term of this sequence. So we're going to have 4 times 4, that will be 16 minus 5, so that will be 11. So the third term will be 11. So super easy. So that is question 5. So the next question is question 6. Here is a distance time graph for a journey, as you can see here. So calculate the speed of this journey. Give your answer in kilometers per hour. Okay, so the speed is given as d over t. If you remember this, distance over time, that is the speed. And the total distance covered here is 60. Okay, so this will be 60 kilometers over the total time taken is from 8 o'clock to 11 o'clock. So from 8 to 9, that is 1 hour. 9 to 10, 2 hours. Then 10 to 11, so that will be 3 hours. Okay, so this will give us 20 kilometers per hour. Okay, so you put 20 here. So the next question is question 7. A prism has a cross section that is a regular pentagon. Okay, so find the number of planes of symmetry of this prism. Okay, so if you take the rectangular pentagon here, from this side you can have a plane like this, that will be 1. So you can have another one like this, that will be 2. Okay, then you can have another one like this, that will be 3. You can have another one like this, that will be 4. You can have another one like this, that will be 5. Okay, and you can have another one like this. Okay, so that will be 6. Okay, so you can have another one like this. So it will divide the two shapes. Okay, the plane shape will divide the shape into equal sides. Okay, so we have 6 all together. So this will be 6. Okay, so part B, the prism has a length of 15 centimeters. The area of the cross section of the prism is 10 squared centimeters. Calculate the volume of the prism. So the volume of the prism is given as the cross section area. So let's say cross section area. So multiplied by the length, let's say L. So the cross section area is given as 10 squared centimeters. Okay. Then multiply by the length, which is 15 centimeters. So if you multiply this by this, you get 150 cube centimeters. So that will be the volume of the prism. So 150. Question 8. Here are some measurements of length: 70 centimeters, 500 nanometers, and 0.4 meters. Okay. So write these measurements in order of size, starting with the smallest. Okay, for you to get the smallest one, okay, you have to convert them to the same units. So let's convert everything to centimeters. This is already in centimeters. So this is in nanometer. Okay, so to convert this to centimeters, let's change the meters to centimeters. That will be multiplied by 100 by using King Henry died by drinking chocolate milk. Okay, so this is the base where you have the meters. Okay, so from meters to centimeters, so 1 2, so you add 2 zeros. Okay, so that means this will be 500. Then let's add 2 zeros, 0 zeros. It will be centimeters now. Okay, so the last thing is to remove this nona. This nona is multiplied by negative 9. Okay, that means we shift the decimal point backward towards the left hand side, so by 9 times. Okay, so let's start from here. This is where this is the location of the decimal point currently. So if you have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the decimal point will be here. So we need to fill up this with zeros. 1, 2, 3, 4. So don't forget that the zeros after the decimal points, okay, so they are useless. So that means this is the same as 0 point. There are many zeros? 1, 2, 3, 4, then 5. So 1, 2, 3, 4, then 5. So the last zeros after the first non-zero digits, okay, is useless. Or the last zeros, okay, or the zeros after the last non-zero digits, okay, are useless. Okay, so if you have 0.300, so it's the same as 0.3. So equally, if you have 0.3200, so it's just 0.32. So that's what I was trying to explain. Okay, so this 500 nanometers, okay, is the same as these centimeters. Okay, 0.000005 centimeters. So of course 0.4 meters, so you have to shift the decimal point twice in this direction. So from here it will be 1 and 2. So the decimal point is now here, so you can fill up this with 0. So you have 040, which is same thing as 40. So this will be 40 centimeters. So now we've converted the numbers to centimeters, so they are equal now. So they are in the same unit rather. So this is 70 centimeters, 40 centimeters. So the smallest will be this 0.0005 centimeters. So, but we're not going to write this. We'll write this. This is the given number and it's equivalent to this. So this is the smallest, 500 nanometers. Okay, will be the smallest. Then followed by 40 centimeters, which is 0.4 meters. 0.4 meters, and the largest will be 70 centimeters. Okay, so let's go to the next question. That will be question number 9. The diagram shows a shape made by joining a semicircle to a right-angled triangle. The diameter of the semicircle is 22 centimeters, as you can see from here. The length of the perpendicular sides of the triangle are 22 centimeters and 31 centimeters, this and this. Okay, so let's scroll down. Complete the calculation for the total area of the shape. Okay, so we have a semicircle, so that will be area of a semicircle. The area of a semicircle is area of a circle divided by 2, that is pi r squared is area of a circle. So divided by 2, that will be 1 over 2 multiplied by this. So this will be the area of a semicircle. Then the area of a triangle will be base times height over 2. So the base is 22 centimeters. Okay, so that will be the base, and the height is 31 centimeters. Okay, so let's see what we have here. So it will be half times 22. So as you can see here, we have pi here. So that means this will be the area of the semicircle, while this will be the area of the triangle. So the area of the triangle is base times height over 2. So we already have over 2 here, that is a half. Then this is the base, then the height will be 31. Okay, so we are done with the area of the triangle. Then we are left with the area of the semicircle. It will be half. So this will be 1 half 2 times pi r squared. The diameter is 22. So the radius is half of the diameter, which is 11. So we'll put 11 here. So this is how to complete that. Okay, so let's go to the next question. That will be question 10a. So Angelique records the resting heart rate for a group of people before and after taking the part in the fitness program. So resting heart rate is measured in beats per minute, BPM. So this back-to-back stem and leaf diagram shows the results. Okay, so this is the results. So before and after fitness program. So the key is 4/4/6/2. That is, if you are for this side, it will be 6/2, that is 62, and for this side it will be 6/4, that is 64. So represent 64 BPM, okay, that is beats per minute before the fitness program, and 62 beats per minute after the fitness program. Okay, so the tables give the information about 6 values that are missing from Angelic's diagram. So resting heart rate before fitness program and resting heart after fitness program. So 5 values are missing here. So we have 5 values missing here, and 1 value is missing here. Okay, so this the minimum value is 49 here. The modal value is 78. The maximum value is 97. So this information will guide us in getting the 5 missing numbers. Okay, so let's start with the first one. So the minimum value is 49. So for this one, so that means 9 should be here. That's the minimum value for this one, 49. So let's go to the table again. The modal value is 78. So let's see the current modal value. So the current modal value here is 65. You can see 65, 65, and 65. We have 1, 2, 3. Okay, so we have 65. 65 appears 3 times. So that means the modal value should appear more than 3 times. And the modal value is 78. That means 78 should appear more than 3 times. That is the implication. And the maximum number is 97. So if the maximum number is 97, so that is 97 should be here. So we have 2 numbers, okay, already. So we are left with 3. So 78 should be 4, okay. And we already have 1 here, 78. So it will be 78, 78, and 78. So 78 appears 4 times now. So it should be more than 65. So 78 is the modal value. So and we have all the 5 missing numbers. Okay, good. Okay, so here 1 number is missing. The range is 45, and no person has a resting heart rate less than 48. So that means 48 is the smallest number there, and the range is given as 45. So if from the formula of the range, it is equals to the highest minus the lowest. Okay, so and the range is 45. Let me cross check that again. Yes, 45. Okay, and no person has a resting heart. No person has a resting heart rate less than 48. Okay, so that means the smallest, the lowest will be 48. So according to the information there, so that means the highest number is missing, of course. So if we do this, it will be 45. Okay, let's add 48 to both sides. Add 48. So this will eliminate this. So this and this will add up to 93. So that will be the highest number. So the highest number here is 93. So this is how to complete this diagram. Okay, so we have completed the back-to-back stem and leaf diagram. Okay, with 6 missing values. So part B, Angelic says there is a greater spread of resting heart rate before the fitness program. Look at this, greater spread of resting heart before the fitness program compared to after fitness program. Draw a ring around the measure that shows Angelic is correct. Okay, so spread, if you want to know how data spread, so we are talking about the range. Okay, so let's go to the next question. That will be question 11. Question 11, the time Pierre takes to solve a puzzle is 12.7 seconds, correct to 3 significant figures. Write down the lower limit for the time pair takes to solve the puzzle. Okay, so according to this number, 3 significant figures will be the tenth, which is this. Okay, so and the tenth is 0.1. So the actual number is 12.7. So let's count in 0.1. Okay, so the next number will be 12.8, and a number before will be 12.6. Okay, so the minimum number, okay, so the lower limit for the time pair takes will be the average of these two numbers. So if it was to be the upper limit, so it will be the average of these two numbers here. So you get the upper limit from here, but we are interested in the lower limit. It will be average of these two numbers. So this is 12.6, so 12.7. Of course, the mid number will be 12.65. Okay, so straight away you can get it like that, or you can take it to be like, although this is wrong, you can say 12.60, so 12.70. You can say that, but in case you cannot get to the answer by saying 12.6 and 12.7, so you can just say 12.60, then 12.70, and the middle will be 12.65. Okay, so although the best way is to pronounce it is 12.6 and 12.7. Okay, alternatively you can add 12.6 and then 12.7 together, so this will give you 25.3. then you can now divide 25.3 by 2. Okay, so this will be 2 goes in 2 once, 2 goes in 5, that will be 2 goes in 5, that will be 2 times, remember 1, so you put the 1 here like 13, then that will be 6, then 5. Okay, so but if you can get it straight away, it's super cool. So that will be 12.65. so that will be the lower limit, straightforward. Okay, question 12. Rajiv substitutes x equals to 3 into the expression 2x squared and get the answer 36. Take this sign to show if Rajiv is correct or not correct. So if you see, actually it should be 2 into 3 to the power of 2. So following BODMAS or BIDMAS, you have to do the power first. Okay, that will be 3 to the power of 2, that is 9. 9 times 2, so the answer should be 18. 2 times 9 is 18. Okay, so this is not correct, and explain why. So you can say Rajiv did not follow the order of operations. You can write, so Rajiv did not follow or didn't follow order of operation, that is BIDMAS or BODMAS. Okay, and some people will use PEMDAS, although that is American stuff. Okay, so another thing you can say because the correct answer is 18, so this is or. So another thing you could say, or you can say that what Rajiv did, how can you get 36, is when you do 2x then everything squared. So this is when you're going to have 2 times 3 then everything squared. So this will be 6 squared, that will be 36. So that means Rajiv did, so that means Rajiv did 2x everything to the power of 2. This is what he did. Okay, and whereas he was asked to do this. Okay, so that is you can pick any of those 3, and if you think of any other one, you could put there. Okay, so it should also be correct provided it goes with the expression there. Okay, so the next question will be question 13. Okay, 4 students each start to solve a different calculation involving fractions. For each student's work, take this sign to show if their statements are true or false. Okay, let's see the 4. Okay, the first one 7 divided by 1 out of 7 divided by 1 out of 8. So it's the same as 7 times 8. Okay, so yes, if you find the reciprocal, so dividing by 1 out of 8 is the same as multiplying by 8. Okay, so this is true. So student 2, 15 divided by 3 over 4 is the same as this. No, so this is false. It's not correct. Next one, 27 times 2 whole 5 out of 8. So it's the same as multiplying 27 by 2 plus multiplying 27 by 5 out of 8. So this is also true. Okay, so it's just like when you have 2 multiplied by, let's say, probably 10. So you can split this 10 into 2. So you can say 2 times, okay, that is 10 is 5 times 2, for instance. Okay, so okay, let's use plus. Okay, so let's say probably something like 8 plus 2. Okay, you can split this 10. So it will be 2 times 8, that will be 16. Add 2 times 2, 4. And this will still give you 20. That is correct. So if you do 2 times 10, the answer is 20. And if you split this into 2, so you still multiply, open the bracket by this, you still get 20. So this is correct. So in this case, for this one, 3 whole 5 over 7 times 6 will be the same as 3 times 6, okay, plus 5 over 7 times 6. So this will not be correct. So this is false. So because ordinarily, if you should write this as an improper fraction, 7 times 3, that's 21, add 5, that's 26. So you have 26 out of 7 multiplied by 6. So if you do this, look at what you're going to get. Compared to this will just give you 3 times 6. So this will be 18. Okay, then plus maybe some 30 out of 7. Okay, so this would be like around, this is not up to 5, so this would be like around 4 point something. 7 times 4 is 28. So we can just say about 28, about, it's under 30 though. Okay, you can just say under 30. But look at this now. If you do this, okay, 26 times 6 alone. So just to show you, if you do 26 times 6, don't forget calculator is not allowed. So you can do 6 times 6, 36, you keep 3. 6 times 2, you have 12 plus 3, that is 186. Oh, sorry, I think I made a mistake here. You do 6 times 6, that is 36. So you have 6, you keep 3. 6 times 2 is 12. 12 plus 3, that is 15. 156. Okay, so if you do 156 divided by 7, so you have 7 goes in 15, that will be 2 times. Okay, as 7 times 2 is 14. Okay, so 7 times 2 is 14, you have 1. 7 goes in 16. If you put the 1 here, that will be 16. 7 goes in 16, that will also be 2, that is 22. As 7 times 2 gives 14. So we are left with 2. Okay, so this will be 22 point something. Okay, so can you see that you will not get the same answer? Why this one is 28? So this one is a little bit larger than the actual number. That is the implication. Okay, so it will be larger than the solution you should get, the answer you should get here. Okay, so that will be false. So these two will be true and these two will be false. Okay, so work out, but if you understand the concept very well, so you don't have to work out this. Okay, so you should know that this will be correct for the reason given, so this will also be correct for the reason given. So when you see something like this, so you cannot split like this. Okay, you can't split like this, and the reason being is the multiplication you have in between. So this is why you cannot split like this. Okay, so at you have addition here, then this will be very correct. Okay, because 6 times 3 plus 6 times 5 out of 7 will be correct, just like what you have here. So So this is wrong because of the multiplication here. Okay, so if you understand the concept, you don't need to do all this. So you just write the answer straight away, because this should be addition. Okay, so that is a fact. So question 14, work out the value of p to the power of 5 plus 10 and over 3 plus 2 to the power 2 plus, over 3 plus 2p when p is equals to 2. So this would be 2 to the power of 5 add 10 over 3 plus 2 into 2. So this would be equals to 32 plus the, okay. So then over 2 times 2, that is 4. 4 add 3, that will be 7. So this will be 42 out of 7. So this will be 6. Okay, so this will be 6. So the final answer here is 6. Okay, so question 15. Yusuf draws the table to record the length of each leaf in a sample of leaves. Okay, we have them like this. Yusuf has made some mistakes in the class intervals. Write down the class intervals that allow Yusuf to record every leaf length. 2 have been done for you, so we just have to complete the remaining one. Okay, if L is less than 10, then here 10 should be less than or equals to L, while L is less than 20. So that will exclude the numbers here. Okay, and it should capture another set of numbers. So that will be 10. Let's write that 10 less than or equals to L, and L is less than 30. So this will cover numbers from 1 to 9, and this will cover numbers from 10 to probably 29 less than 30. Okay, so the next one will be numbers from 20 less than or equals to L, and this is 20 here, less than 20. So why this will be 20 less than L, less than or equals to L, and L is less than 30. So this one will cover, this one covers numbers from 10 to 20, 10 to 19, while this covers 20 to less than 30, maybe 29. And if you have a decimal number, maybe 29 point something, while this covers numbers with numbers from 30 upward. Okay, so that will capture all the numbers there. Okay, so the next question will be this. Okay, we have to use board mass. So we start with division. So this will be 1 minus, so 7 out of 10. So dividing by 7 out of 1 is the same as multiplying by the reciprocal, 1 out of 7. So this will cancel this. So we're left with 1 minus 1 out of 10. Okay. So if we are subtracting this, okay, the shortcut is to say 10 minus 1, that would be 9, okay, out of 10, okay, straight away. But if you want to show your working, so you can just do 1 minus 1 over 10. So this would be like over 1. So you can just, I want to have common denominator, so multiply this by 10, multiply this by 10, okay. So multiply this by 10, multiply this by 10. So if you do that, so I'll have 10 out of 10 minus, this should be, multiply this by 1, multiply this by 1, okay? Because 10 is here, then 1 is here. So you multiply this one by 10, then you multiply this one by 1, okay? So this will be 1 out of 10. Now they have common denominator, so you can just do 10 minus 1, that will be 9 out of 10, okay, because you can only add or subtract the numerators if and only if the denominators are the same, okay. So we have 9 out of 10 left here. So part B, we want to evaluate this. So let's write this as an improper fraction. So that will be 5 times 1, 5. 5 add 3, that will be 8 out of 5. Then multiply by 8 times 4, that will be 32. Add 1, that will be 32. 3, okay, out of 8. So this can cancel this, so we are left with 33 out of 5, and 5 goes in 33 6 times, means there are 3 out of 5. So this will be the final answer to this, okay, 6 or 3 out of 5. So pretty easy and straightforward. So the next question will be, okay, let me see, this is question 16. So we have to go to question 17. Question 17. Solve the simultaneous equations. So here, we need to use the elimination method. Okay, so let's balance the coefficient of y. So the coefficient of y in this equation is 1. So I can multiply the whole of equation 2. Okay, so if I name this equation 1, name this equation 2. So in equation 1, the coefficient of y is 1. So I can multiply the whole of this by 1. So apparently, it will not change anything. Okay, and the coefficient of y in equation 2 is 2. So I'll need to multiply equation 1 by 2. So if I open the bracket, this will be 6x add 2y, then equals to 2 times 14, that will be 28. So equation 2 remains the same. So this will be 5x, so plus 2y equals to 25. So I can now eliminate y. So I need to put minus here for me to get the 0 here. So I will put the same sign here. 6x minus 5x, that will be x. Then equals to 28 minus 25, that will be 3. So this is nothing. So because we have plus 0, so it is nothing. So we have x equals to 3 straight away. If x equals to 3, then I can substitute into either here or here or here or here. So let's substitute into equation 1. We have 3x. So x is 3 now. So this will be 3x as x equals to 3 plus y, then equals to 14. So this will be 9 add y equals to 14. So let's subtract 9 from both sides. This will cancel this. We have y equals to 14 minus 9. That will be 5. So that means x equals to 3 and y is equals to 5. Question 18. The diagram shows a triangle ABC. ABD is a straight line. ABD is a straight line. Okay. So angle X is an acute angle, and angle Y is obtuse. Is an obtuse angle. So that means angle X is less than 90 degrees, and then angle Y is more than 90 degrees, but less than 180 degrees. Okay, so what we can do here, the exterior angle Y is an exterior angle to triangle ABC. So, and there's a theorem, the exterior angle to any triangle is equals to sum of the opposite interior angles. So that is, angle Y will be equals to angle X plus angle 100 degrees. Okay, so this is one fact. So, we know that the sum of angles in triangle ABC is 180 degrees. So if this angle is 100 degrees, that means angle X and this angle need to share the remaining 80 degrees. So of course, the angle here will be less than 80 degrees because this cannot be 80 degrees. So this and angle X, okay, have to share the remaining 80 degrees. So that means we can say X is less than 80 degrees. So it can be any number. It can be 30, it can be 20, it can be 50, it can be 15, it can be 70. Okay, it can be 78, it can be 79. In as much this, sorry, it cannot be 79 rather. Okay, I think it can. It can. So although this will be very small to be 1 degree. Okay, so but the fact is that this is less than 80 degrees. So it can be 79 and this will be 1. Okay, but that is a very small angle because X is an acute angle, so it is less than 90 degrees. Okay, so what I will do now, we are asked to find one possible pair of values for angle X and angle Y, one possible. So any value of x that is less than 80 degrees will be correct. So for me, I can choose x equals to 30 degrees. So I can say x equals to 30 degrees. Okay, so if x equals to 30 degrees, then I can now get the value of y from here. So y will be 30 plus 100 degrees. So it will be 130 degrees. Okay, you can see this is an acute angle and this is an obtuse angle. So if you like, you can take the value of x to be 20 degrees, then y will be 20 plus 100 degrees. That will be 120 degrees. So we have many numbers we could choose from. So I'll stay with this 30 and then 130 degrees. Okay, pretty straightforward. So the next question will be question 19. In question 19, the diagram shows shape A and shape B on a coordinate grid, as you can see below. Okay, so shape A is transformed onto shape B by a combination of two single transformations. The first transformation is a rotation of 90 degrees clockwise about 0, 0. Then describe fully the second transformation. Okay, so if you have this is the shape A, the object, and this is shape B, the image. So if you rotate this, okay, along the origin as stated in the question, okay, so and it is rotated clockwise, okay, 90 degrees. So it should be, okay, can I draw something here? Let me see. Okay, so this side, okay, let me label it. So if I say A, then B, C, okay, or let's use, since we have B here, so let's use P, Q, R, and S here. So if I rotate this clockwise, 90 degrees clockwise direction from the center of origin, okay, that's the center of rotation. So side PQ should be here. So to be Q should now be here. Okay. So now for PQ, and it's the same thing as this now. This should be P and this should be Q. So for PQ should be here now. That means after the rotation, it was reflected along this line here. X equals to -1. Okay, x equals to -1. So this will be the mirror line. Okay, because from here you count to 1, 1, 1. From here you count to 1, 1, 1, and so on and so forth. Okay, so that means the second one should be a reflection. That's what we just write at x equals to -1. So one mark for this and one mark for this. So let's see, let's scroll down. The next question, that will be question 20. Write the letter for each calculation in the correct place on the Venn diagram. One has been done for you. Okay, let's see the Venn diagram. So you have this. If it is less than 86, if it is less than 8 to the power of 6, write it here. Okay, inside this bigger circle. And if it is equals to 1, write it inside this smaller circle. So if it is greater than 8 to the power of 6, so write it inside this circle here. And if there is any number that does not belong to any of these three circles, but is part of the population, so you can write it anywhere outside the circles, but inside the rectangle. Okay, so let's say the first one, 8 to the power of 2 times 8 to the power of 2. So this is multiplication of indices. It will be 8 to the power of 2 add 2. That will be 8 to the power of 4. So which is less than 8 to the power of 6. So A is written here. Okay, then B, this will be 8 to the power of 2 add 3. That will be 8 to the power of 5. Okay, so that means we're going to write, you can put comma here or simply write B. So B will also be here. And C will be division law of indices. So we pick one of the bases. So this will be 8 to the power of 15 minus 5. That will be 8 to the power of 10. So C will be here. Then any number to the power of 0 is 1. So D will be equals to 1. So we'll put it inside this. So D is equals to 1. Then this 8 to the power of 1 is the same as 8. So 8 is the same as 8 to the power of 1. So this will be 8 to the power of 1 plus 5 plus 1. That will be 8 to the power of 7. So which is greater than 8 to the power of 6. So we can actually write E here. I think let's recheck that again. E, okay, that is correct. And here, this is power law of indices. So we have to do 8 to the power of 2 by 3. So that will be 8 to the power of 6. So this is exactly 8 to the power of 6. So it cannot be in this big circle, and it cannot be in this smaller circle, and it cannot be in this. So it will be in the rectangle, inside the rectangle, that is outside the circles but inside the rectangle. It means number that does not belong to any of the given circles. Okay, so you can write it here, you can write it here, you can write it here, you can write it anywhere in the rectangle. So I'll just put 8 to the power of 6 here. So that is how to complete that. Still have 4 to go. So question 31. Jamila writes these rules about fractions and their decimal equivalent. Tick this sign to show if each of Jamila's rules is true or false. Fractions with an even denominator will always be equivalent to a terminating decimal. Now you have to know a fact. The fact is this: for terminating decimal, you can only have the terminating decimal if the denominator is a power of 2 or 5. Okay, let's take for instance now, if you have 1 over 2, this will be a terminating. So power of 2 will be 4. If you take 1 out of power of 2, will be 2 to the power of 2, that is 4. So this one will also be terminating. So if you have 2 to the power of 3, that will be 8. So 1 out of 8, and so on and so forth. So if you have power of 2, okay, it works like that. And also if you have power of 5, look at 1 out of 5, it will give you a terminating decimal. So if you now have power of the next power of 5, that is 1 over 25, it will also give you a terminating decimal. That is 5 to the power of 2. So 5 to the power of 3 is 1 over 125. It will also give you a terminating decimal number. So any number that contains this power, okay, will be a terminating decimal number. Okay, so fraction with an even denominator will always be equivalent to a terminating decimal. Okay, so let's look into this. If you have 2 as an even number, fine, we are sure. If you have 4, so what if the number is not a power of 6, a power of 2 rather? So let's take for instance 1 out of 6. Okay, so 6 is not power of these 2. Okay, so that means this will give us a recurring decimal. It will not terminate. 6 goes in 1, that will be 0 times. You put decimal point here, then you have 10. 6 goes in 10, that will be 1, remainder 4. Okay, so and so on and so forth. So 6 will continue to show 6, 6, 6, 6, 6, and so on and so forth. So this is false because it has exceptions. Okay, if the even number is not a power of 2, okay, so then it will it will be a recurring decimal number. It will not terminate. So that will be false. Fraction with a denominator which is a multiple of 9 will always be equivalent to a recurring decimal number. Here, if you have any factor of 9, okay, will always give you a recurring decimal number. If the denominator is a multiple of 9, okay, it will always give you a recurring decimal number. Or better still, if you say multiple of 3 as well, okay, so it will always give you that. But it has an exception. Okay, so that is, okay, I'm coming 1 out of 9, okay, will give you a recurring decimal number. Okay, and anything that contains maybe what's it called, if the prime factor contains 3 or you have multiple of 9 thereabout there, okay, so it will always give you this recurring decimal number, excuse me. Okay, now but it has an exception. The exception will be when this only works for it only works for proper fractions. When you have proper fractions, so it works very well. Okay, but let's say you have something like 9 out of 9, for instance, or you have 18 out of 9. So 9 out of 9 will give you 1, which is a terminating decimal, not recurring, so it will be 1.0, for instance. And 18 out of 9 will give you 2, which is the same as 2.0, which is a terminating decimal. So you can see that for this and this, even though the denominator is 9, okay, you can see that we still got a terminating decimal number. So this rule only works for proper fractions, okay, but when you have improper fractions and the likes, okay, so it will terminate. So that means it is not always true. So this will also be false as well. So you just have to understand these facts for you to be able to get this straight away. Okay, so let's go to the next one. That will be question 22. Naomi has a bag containing 5 counters, each with a different number written on it. She also has a bag containing a bag. Sorry, I'm getting tired. She also has a bag containing 10 counters, each with a different letter written on it. Naomi picks one counter at random from each bag. One possible outcome is this. Okay, so this is just a sample that how you can connect the numbers and the letters together. Okay, so if you see, okay, you can actually do something. If you spread the numbers like this, like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, okay, something like this. Then we spread the letters like this. Let's say, for instance, maybe A, B, C, D, and E, for instance. Now, you see, each letter we generate 10 outcomes, because 1A, 2A, 3A, up to 10A, that will be 10. So this will be 10, this will be 10, this will be 10, this will be 10, this will be 10. So you should have 50 possibilities. Okay. Then part B, Naomi has these 5 white cards and these 3 gray cards. Naomi picks one white card at random and one gray card at random. Calculate the probability that both cards show a number greater than 3. A number greater than 3. Okay, so what's the probability of number? So she selects 2 numbers randomly, the first one and the second one. First and the second. Okay, this and means multiplication in probability. So one white card at random. So let's pick one white. Okay, so this is the order: one white and one gray. So let's pick one white first. So one white will be greater than 3, to be 4 and 5. So that means we have 2 numbers out of 5. So this will be 2 out of 5 for the white. And for the gray, we have only this to be greater than 3. That will be 1 out of 3. So you have 1 out of 3. So if you multiply this will be 2 out of 15. So that will be the final answer. So let's scroll down. So you can put 2 out of 15 here. So the next question will be question 23. So if it is given that 0.71 times 10 to the power of n equals to 71, and 2.3 times 10 to the power of p equals to 0.00023, find the value of 0.067 divided by 10 to the power of n plus p. So we need to find the values of n and p. So that would be 0.067 divided by 10 to the power of the sum of n and p. So we can find n and p from this given information. So if you have 0.71 and you multiply by 10 to the power of n and it becomes 71, so that means you have shifted this decimal point to the forward. So let's see, 1 to be here and 2. So the decimal point will be here. That's where you get 71.0, which is 71. So that means n is equals to 2 from here. N is equals to 2. From here, you have 2.3, and 2.3 has become 0.00023. So if the decimal point is here, okay, and it is now here, okay, so that means from here you should come like this: 1, 2, 3, 4, and 5. So that is towards the negative side. That will be minus 5. So that is the implication. Oh, sorry, let's count that again. Is it up to 5? So from here, 1, 2, 3, and 4. So that is minus 4. So P is equals to minus 4. So that is how you can get this. So we can now put the values of n and then P here. So n is equals to 2, add P is equals to negative 4. These two signs combine together to become negative. So this will give me 0.067 divided by 10 to the power of 2 minus 4. That will be minus 2. Okay, now dividing by 10 to the power of negative 2 is the same as multiplying by 10 to the power of 2. So that's just another fact. Okay, so you can now multiply this 0.067 by this. So if you shift the decimal point to the front 2 times, because we have positive 2 here, so this will be 1 and 2. So the decimal point will be here. That will be 006.7. So that will be 6.7. Okay. The last question, question 24. Here is an algebraic statement. So we have this expression, the left hand side to be equals to the right hand side. So we need to find the value of c. So we need to expand this bracket. So this is the same as x add 3 into x add 3 plus c, then is equals to x minus 3 into x plus 5 plus 4x. So let's expand. So if you expand this x and x, that will be x squared plus x times 3, that will be 3x, plus 3 times x, that will be 3x, plus 3 times 3, that will be 9, then plus c equals to x and x, that will be x squared, x and 5, that will be plus 5x, minus 3 and x, that will be minus 3x, minus 3 and positive 5, that will be negative 15, then plus 4x. Okay, so we can add these two together. So we have x squared plus 6x plus 9 plus c equals to 5x minus 3x, that will be 2x. 2x add 4x, that will be 6x. So we have x squared plus 6x minus 15. So x squared, we cancel x squared here, plus 6x, we cancel plus 6x. So we are left with 9 plus c equals to negative 15. So let's subtract 9 here. Subtract 9 here to get the value of c. To be equals to minus 15 minus 9, that will be minus 24. So this is the end of my solution to paper 1. In the next video, I will solve all the questions in paper 2. Until then, have your fingers crossed.